All right. Good evening and welcome to the webinar. Our special guest, John MacKay, has earned his bachelor's in chemistry from St. Lawrence University and his Ph.D. from the University of Vermont in chemistry, focused on the noble cause of synthesizing compounds for cancer-fighting agents. After positions of teaching at various colleges, John joined the Waters Corporation in 1983, where he had a decades-long career and currently is working in innovative product development and leading the strategic technology team. He is also the founder and CEO of Synergistic Technologies, as well as an adjunct professor at the University of Vermont. John, when you're ready, please share your screen and we can get ready. Do you copy, John?
I do. I do. I'm just trying to figure out how to share the screen. So I think I'm getting there. Did I do it?
Oh, there you go.
Thank you so much. I appreciate the time and the opportunity to speak tonight, as well as having the recordings so it's available for people afterwards. And for me, it's an opportunity to be working with the organization that's looking at therapeutical and medical research with cannabis. But it's also, as we see the technology moving and the processes moving over the last few years, we've seen cannabis has moved from the backwoods and basements and storage sheds to state-of-the-art facilities for cultivation, for genetics, and a lot of other opportunities, and exploring that from the United States, but across the world. So I'm going to figure out how to go to the next slide. There. Hopefully I've done it. So a lot of the things that we see in the challenges in the cannabis space, and as we move forward to be looking at testing all across the process, is a lot of the what I would call sense-centric. And sense-centric means, to me, smelling or visual or taste or touch or experiential methods of deciding when the product is of the quality you need and to be able to have the therapeutic possibility. And then secondly is what I call University of YouTube and other social media, where learning about how to do cultivation or extraction has been more underground rather than through some of the research facilities, and merging those two technologies, as well as underground textbooks and other written social medias that are out there. I think the other challenges we've seen is an inconsistent local regulatory standards, where each town and each township or city has a different regulatory standard outside of even the state or the national or international laws. This is seen all across the nation, but certainly Denver, Colorado has more stringent regulations than the state of Colorado, and is certainly one of the places that would be different from Oregon or Portland or Washington, Seattle, each one as it's been standardized. And then the third part is, as people have moved forward on why bother investing in tools when everything seems to be going okay. And those are some of the challenges that we've seen moving forward. But part of my process is good is not a number. And the more I was within the industry over the last 5 years, trying to work towards more regulatory, more safety standards, it became apparent to me that more and more people would say, this is really good. The product is good. And for me as a scientist, I'm more comfortable with having either percentages or grams per kilogram, for example, CBD at 10% or CBDA at 6%, so that you actually know what's in that formulation, so that if it is a therapeutic, then you'd be able to have more people know exactly what you have. The other part is faster. An extraction side of ethanol is faster than CO2 supercritical, or butane's faster than Freon, or their fluorinated carbons. Each one of these has to be moved towards a rate per milligram, and each one has different milligrams per minute. Each one has a different rate, and being able to move forward from that of what's your rate per second, and looking at the reaction, at the kinetics of extraction. And the other one is I cut a lot. And each one of these is not SI units. And again, if I was to look at how much I was expecting to have from a yield of 5 pounds and how much I actually got from 5 pounds, and then all the way through the process, from the extraction through the purification, for example, or winterization, following that process all the way through. And so part of this is moving from the subjective to the objective. And it makes a difference as we're moving through the quality control and having something that's of therapeutic or medicinal research. The seed genetics. A lot of people looking at where the seed was from originally. If the seed was from a very dry climate and then you're placing it into a very humid climate, those are two different things for the seed. It grew from different criteria. Also, taking samples throughout the growing process from leaves and flowers, it's very possible, even after the first 4 leaves that come out all the way through the process, to know what the percentage of the cannabinoids or terpenes or other components are in that plant. And then following that through the drying and the extraction process. The extraction itself with yield and kinetics is certainly important. And knowing that if you are losing product from the original seed genetics, then that's something to be aware of. From shelf life and potency, contaminants is certainly in the headlines as far as pesticides. And even though someone hasn't used pesticides, there's a carryover, there's a wind, there's something from the soil. Each one of those has to be controlled, and that really brings you to an internal R&D for enhancement and protection, and being able to know that you are making solutions. And it doesn't have to go through a validated ISO 17025 laboratory. You really need to be able to have a handle on some of the potency throughout the process without extensive instrumentation. So most of the time what I see, the merging of science and economics in all of the natural products, and no matter what the plan is, everyone's plan is wonderful. It's a straight line. Everything is just fabulous, and it's downhill and it's straight. And each one of those tends to be a little off center from what reality is, whether it's what kind of extraction to put it in, what kind of pesticides, what are the limits to detection. Reality is more of this, and that is, it's not a straight line. There's different challenges all the way through the process. And cannabis in its own right is a challenging matrix, as well as in today's with a number of varieties. Each one has its own extraction characteristics, as well as the final formula that people want to be able to make. Very much a formulation centric, and the extraction you're choosing should be based on the formula you're finally trying to make. And extraction is painful. Extraction has evolved over the years, but it's still a painful process for those that are moving into it, and for those that think it's simple. And even with today, with the modern tools of extraction, having your molars out is something that most people can go back through and either know that they themselves went through pain or others did. And the extraction is the same way, no matter what you're looking at. And we're going to look at botanical products. I've shown this slide a few times, and I do want to make sure that people understand that this slide is actually a joke. And a lot of times people have asked me, well, gee, I want to have a magic botanical filter, an MBF. There is no MBF. Most of the time what people are trying to do is they have the terpenes or the cannabinoids or other stuff. I call it fats, lipids, and waxes. And what they really want to do is, press the button and out comes a fully, purified product. And that's not what's going to happen. The real key question is what's the question that you're trying to answer? And from there, we'll look at some of those processes and see how they evolve. The cannabis plant itself, and this is a paper that certainly is well known. And if you were looking at the number of chemicals and processes within the plant, it's very detailed. Within delta 9 itself, there's 9 isomers. And so there's 9 different forms of delta 9 THC. There's 2 forms of delta 8. And for all the parts that we're looking at for the CBD, for example, there's still 7 known isomers of that. So each one is in its complexity. And then you look on the right-hand side and see the number of other compounds that are in there, flavonoids, vitamins, pigments. There's a lot of things that come out, and that's why you can't have a magic filter. But I would still say that there's a way to choose what the best extraction is. And so I've used this one a number of times, and B stands for Botanical Materials Integrity, maintained to assure that the extraction of the desired components are in their natural form. Being able to make sure that you have a full spectrum, or whatever your goals are, that's your best key for the botanical materials. The extraction, efficacy, efficiency, effectiveness, and economics. I love alliterations. It's my slide, so I've made it up. But if I look at that, those are predetermined boundaries. So it's the extraction efficacy. Is it ethical? And then looking at the efficiency and the economics. Each one of those must be held in boundaries for a business or for a research facility. S is for safety. Safety of everyone throughout the workflow process. I used to first have safety as far as the patient, and the patient is critical to have the safety to make sure that what you're providing a patient or in a therapeutic possibility is safe. But it's all the way through the process, from the pesticides being placed on the plant, when they're done, how they're done, the safety of the workers who are, tending to the plants to make sure that they are safe, the workers throughout the process. And so each one of these is critical to be looking at. And then testing with modern technology. Certainly every facet of this can be tested with modern technology and moving us from the subjective to the objective. And there are a number of different things that you can look at as you're scaling and to looking at efficacy and efficiency. Over on the far top right, when I'm looking at grading, grinding, rolling, wetting, each one of those has to do with the preparation of the feedstock before you ever get to any extraction conditions, no matter what the solvent is. And as you go through the very easiest part, the top middle on the extraction conditions, those are the very simplest modes. As you start to move through and want to gain more efficiency, you start to move towards that middle section where you're looking at recycle effects, entrainers and co-solvents, the extractor size, the configuration, how you're doing it. Each one of those becomes more complicated, but also drives you with very, very simple testing to be able to get to those answers. And on the bottom side, it's the optimization. So as you're moving through the process from a very simple to a very more comprehensive, you're being able to know what those capabilities are. Over on the right-hand side is more towards if you're starting to move towards purified compounds or more segmentation of the different components and families. So whether it's conditions or fractional separation, each one of those comes into process as you're moving forward. And as we look at the segments, the obvious 2 segments are with solvent and without solvent. And in the middle, the hybrid between those 2. So let's look at, for a small diversion. So keeping up with your heart rate. How do you measure your heart rate? You typically measure your pulse, and you count to 15 seconds, and you multiply times 4, and that tells you the number of beats per minute. It seems like a good idea to be able to measure our pulse. And we do it every once in a while. But now we have technology out there that allows us to be measuring it all the time. Where we are and what we're doing, sleep, mileage, where did I drive, where did I ride my bike, what's just my typical restful sleep versus light sleep versus wake up, time to fall asleep. So this poor person took 15 minutes to fall asleep. And from that side, you're able to go back through and see what the efficiency is. We're doing this with our heart rate and our breathing rate and our sleep. But somewhere along the way, we pass by what we're doing for scientific process on extraction. But it still can be the same thing, from something as simple as taking your pulse to something as complicated or more comprehensive as online. So let's look at a couple of ways that we can be measuring material. One is called thin layer chromatography, a very simple a technique, fairly inexpensive. You place some of the sample onto a special paper, you place it into a solvent, the different components move at different rates, and then you're able to find out how much each one of those components is. A very simple mechanism. And you can do that even with the most simplest extraction. Here showing the same TLC above, thin layer chromatography, and then below looking at some standards. There's THC, THCA. You can see where the different standards are. And then over on the far right-hand side, you can see different types of compounds that were tested. And so you can see the different components that would be in there, giving you a good idea as far as what you have for an extraction or what you have for the starting material. Each one of those allows you a strong capability of visibility into your technology. This would be like taking your pulse. And then you can move towards liquid chromatography. Liquid chromatography is very similar to thin layer. It's just separating the components. And then through the digitize of looking at UV spectra at different wavelengths, you're able to find out from the standards and from a sample what's in that sample based on what the standards time of retention would be through a column. Much like it was moving up the paper, the chromatography moves it in a time base and will give you a capability. It gives you more visibility into what you have for the components along the process, and we'll see that in a bit. So if I look at those two processes, the one on the left-hand side obviously being a thin layer chromatography, and then the one on the right-hand side looking at liquid chromatography, you can see very quickly that you're able to get more information, more detailed information than you are on the left-hand side. But the left-hand side still brings you a significant amount of understanding about the products. You don't have to spend $140,000. You can spend more in the $600 range, even less, to be able to know what's happening with a sample, giving yourself visibility. As you move towards supercritical fluid chromatography, you see in the green versus liquid chromatography, you need to see in the top. When you look at supercritical fluid chromatography, it's based on the same principles that you see with supercritical fluid, or whether it's CO2 or butane or propane or water, any of those modes. And you can see what it really does is you can see from the liquid chromatography that the acids and the neutrals are a bit scattered. You have CBDA, and then CBD comes out later. You have THCA at the end, but THC comes out before. When you look at supercritical fluid chromatography, you can see over on the left-hand side, all the neutrals come off first. And there's a space between 3.9 minutes with CBG over to THCA at 4.2 minutes. That's quite a long, quite a space. And so if you were to have anything less than the 3.9 minutes, you would know that it was most likely a neutral, even if it was unknown. And if it was over to the right, you would know most likely that it was an acid. This is the same way that supercritical fluid chromatography will be able to be extracted. The neutrals come off first, they're more soluble. The acids come off later. And we'll see this when we look at extraction. So on my side, I typically have a little carrying case that I use in my work over on the left-hand side, and I have my solvent and such. And it's a very simple criteria, just to have something that's in 13 minutes to give me an indication greater than TLC, but not as specific as liquid chromatography, high pressure liquid chromatography, to give answers. And it's over on the right-hand side. You can see that it's gotten ahead of me at the airport. And the typical answers, giving you 6 components. Over on the left-hand side, that's a sample of a plant after decarboxylation. And there's probably no one here that believes that decarboxylation went to completion. As you can see, THCA is still 9.4%, and the delta 9 is at 1.1. What actually happened through this process is the customer probably didn't have a high enough temperature, and so really wasn't getting a decarboxylation. They were getting rid of moisture. And on the right-hand side, you can see the non-detect on a lot of the components, but you can see the CBD is at 82%. And this was after first pass through a short path distillation. So you can see that they're moving typically from the 10% a plant might have to 40 or 50% that you might get from extraction, and then up to 82%. So you can see that you're following the process to know where you are, rather than it looks good. So all the way through the different phases of research, formulation, certificate of analysis, and ongoing research from shelf life, each one of these processes has historically been able to be used through technology and knowing what the actual objective numbers are. So now we're going to look a little bit at how this applies to supercritical fluid. And I'm going to be looking at carbon dioxide as an example, but please know that there's other ways to be doing that, and certainly the carbon dioxide is not your only solvent that can be used. But in this case, no matter which form it is, over on the left-hand side, I've made a pretend vessel, and the solvent goes in from the bottom, the CO2 at whatever pressure and temperature and density it is, and then as it exits, it's the solvent plus A plus B. But it's more than likely even greater than A plus B. It's A plus B plus C, D, E, F. But the major components in this case, we'll look at A and B. And each one of those has to do, so from the time the solvent enters the bottom and within 1 millimeter, it's A plus B plus whatever moisture's in there, plus whatever volatiles are in there. Each one of those moves along the transport as it moves out the back side of the vessel and is collected. So let's look at something simple, and the numbers will make sense in a while. So number 6 is actually a vessel of CO2 pressurized. We're able to go through a gauge, we're able to go through a pump, and then moving into number 1, which is the vessel. So as I look at that vessel, that's going to be the one that I filled with material. From that material, it now moves out through a pressure regulator so that I can know what my pressure is, and then I'll collect it into a vessel. And then the CO2 goes back around, and in a closed system goes back around, around, and around. So what I'm trying to do is I extract something, and then I collect it in vessel number 4, leaving behind all the material that I don't want in vessel 1. Then I can continue to add on to that to be able to have different vessels at different pressures and temperature, and having it more and more sophisticated and getting greater and greater differentiation on the backside. So my collection side through vessel 1 would be at a pressure of, we'll say, 100 bar, and we have a temperature of 45 degrees. And then what I do in the first vessel, collection vessel, I would be dropping out waxes. The second one, I'd be dropping out other cannabinoids, and the third one, terpenes, for example, based on the different precipitation. And in that case, that's what it would look like. So typically without testing, you're thinking, yeah, it looks pretty good. Looks like I got a lot. And it was pretty fast. So those are 3 things that don't bring any objective, and it's certainly sense-eccentric. If you look at number 1, though, you can see from what we did from the bottom to the top was that it's very light on the bottom and dark on the top. So as I was looking at that, you can see that you haven't gone to a full extraction. If I turn that on its side, so now I'm looking at the side, you see from the bottom of the vessel on the left-hand side to the top, you can also see that there's clumps. So it really does show that there was some channeling that's happened through the process. And from those clumps, it's a matter of analyzing from the left to the right on how much material is left in there. And if you take a cross-section of that clump, you can see the green and the light parts. So now what I'm doing is I've taken a section from that and I'm looking down at it. You can see around the outside edge how light it is. You can see in the middle some lighter parts, and then you see the darker parts. And what that really is it's channeling. And so what's happening is you're not extracting everything from that vessel. So you are not getting a full extraction. Let's look what that looks like in numbers. So when I look at that in numbers, this is a projection. This is a representation of 9 different points from that extraction vessel. So across the bottom, you can see how light it is, and you can also see that it's about 0%. I won't say it's 0.0, but certainly less than 1. Then as you move towards the middle, you see that there is a little bit of material, not much left on the left-hand side, and about 3% in the middle. And on the right-hand side, you can start to see that it's about 10% is left. And as you look at the top, you can see that there's a significant amount of material still left in that vessel. This allows you now to say, well, it's light on the bottom, dark on the top. But now it gives you actual numbers. It gives you something that now you have a process to be looking at objective numbers. And good is not a number. If I was to look at this and put it into low terms of dollars, and even on the, the lightest side of retail and wholesale, you can see that a significant amount of money has been left over into that process. So even if I took the top and I said, 2 plus 2 plus, that's about $6,000 across the top, and maybe it's almost $3,000 in the middle. So what you've left behind is a significant amount of money, but also that for the therapeutic value, but it's a waste of material. And so knowing that what you're wasting each time allows you now to look at the process and think, how can I make that better? What is happening within the process? Are all extracts channeling? No, here's some representations. The one on the left happened to be one that I had taken from a customer, and they had done a great job. They had gone from changing things that were having a poor extraction and put processes and procedures in place, and now you have a non-detect. That doesn't mean zero, but it's probably under 1%. And the laboratory results that went to a local laboratory of 17025 showed that all of them were well under 1%. On the right-hand side, it's not just CO2. This is an extraction that was tested afterwards by butane, and this customer also has a great process in place and was extracting everything that was in that container. So it is possible to move from losing money to having non-detect and having a process in place. But again, how would you know without doing the testing and the numbers? As we look towards other parts of the process, so it's not just the extraction. In this case, let's look at the biochemistry of the plant. So you have CBGA, and CBGA can do a decarboxylation to CBG. But CBGA plus CBDA synthase or THCA synthase, that compound is then chemically changed over to THCA or CBDA. Going to the next process, your THCA can be oxidized, whether it's air or time or heat, over to CBNA, and also down to THC and over to CBN. So there's a number of different routes that you can go down to CBN as a product that you could monitor to say, am I having a transfer from my active components into waste products? And how do I stop that? That would be something that you would look at for shelf life. That would be something you would look at for decarboxylation. What are my standards? How am I doing this? What's my oven temperature? On the CBDA, you can see also, have you got the full decarboxylation? Remember when we looked earlier on at the supercritical fluid chromatography and talked about on the left-hand side having the acids, on the left-hand side having the neutrals, and on the right-hand side the native components, what we will call acids in this case. And when you drop off that carboxylic acid, it becomes more soluble, and so therefore you'd have an extraction. Many people will look to do a decarboxylation before they extract because they realize that it's going to be more soluble and you have a greater component. But let's look at a few studies where we can look at this in more detail. Here's a decarboxylation process. So these are the first graphs are showing starting material, and then the other 3 after 2 hours, after 2.5, and after 3 hours. In this starting material, THCA was at 5.2%. That's the blue bar. The orange bar would be THC, and that was at 4.6%. And then the potential THC is by taking and assuming that you're going to have 100% conversion from THCA, the blue bar, times 0.877 with the loss of the carboxylic acid group. And so you have a potential of 9.5% if you did a full conversion. And that's the gray bar. So the most perfect situation would be, in the end, to have the gray bar staying at 9.5% and the blue bar go away. That would be 100% conversion. That's That's going to be tough to do no matter how good an organic chemist you are. You can see that the CBD was still sitting there at about 1.7%. So you can almost use that like an internal standard because that's not going to decarboxylate. You can also look at this and say, this material is a little old because why has it already moved over to THC? You've already got some aging happening here. Another indicator. As I look after 2 hours, you can see that my THCA, the blue bar, has gone down to 1.5%. You can see that the orange bar has raised. That's a good thing. So you know you are doing some decarboxylation. The concerning factor is the gray bar, going from 9.5 down to 8.9. That's a concern because now you're losing your potential. You've already lost percentage of the total product. As you go to 2.5 hours, as far as taking another sample and looking at that, you're now down to even less. You're down to 1.3, but that's not a whole lot more than 1.5. And you can see after 3 hours, you're down to no THCA. The bad news is that you're also looking at a loss of the THC, and all those different processes are coming into play. And the bad news, of course, is the potential THC. So when you're looking at this and someone needs on their side to be able to do either more vacuum, a different temperature, stop it sooner, put it under inert atmosphere like argon or nitrogen, and that's the process that you want to do. But it's looking at the numbers and being able to understand that even though you're doing decarboxylation on your extraction side, you may not be gaining anything. And again, this just looks across that number. They're literally evaporating their dollars. Let's look at the early analysis of a hemp plant. So the red square is a plant, and from that red square, it took a leaf. And from that leaf, you can see underneath the leaf, even after this is probably a 4.5, 5-week-old plant, you can see that there's a lot of different trichomes under there and plenty to be able to do an analysis. So even early on, as you're looking at a plant, you're able to do an early analysis, in this case, a hemp plant, and making sure that you don't have Delta-9 in the process. So you're trying to grow something that is hemp. You're wanting to make sure that you haven't got a strain that somehow has THC. And early on, rather than waiting through the entire process to be surprised at the end that you have THC. The other process is when the compound is done for full extraction. So an extraction system is not only taking out what you think, but it's also taking out everything else. So the active ingredients I have in yellow on the scientific side, but there's also a possibility of mold or contaminants. There's possibility of pesticides that even on very small amounts, trace amounts, when extracted, could go above the levels of what you want. And sadly enough, people putting in adulterants. On the economic side, you have a certain investment that you've made. You had to buy it, or you had service, you had utilities, you had facilities, everything that would happen throughout the extraction process, as well as amount to sell, the dollars to buy, what's your dollars per gram, being able to optimize each one of those, because as we're moving forward, the regulations are going to increase, the margins are going to decrease, and therefore you're trying to still optimize and having a safe product as those margins get squeezed from both sides. I did put HR and adulterants in red just because it's my slide and it seemed amusing at the time. So let's look at another example, looking at numbers rather than good. So the starting material, in this case, the starting ground material, THCA was at 5.4%, THC at 7.8%, and the exhaust, the raffinate, what was left over, was 4 as a total raffinate, totally mixed up. So now it's at 4.3%, and THC was at 1.3. So this is averaging an entire 5 to 10 liter amount of material. So what do we see on this side? We see on the top side that certainly the THC is more soluble, and most of it's gone. Not entirely gone, so we know that there's still some work to be done. Look at the THCA. So even though the customer did not know at the time that they still had a lot of material left over, and so hardly any of the THC, so the conditions have to be changed. And when you look at your first ratio, it's 1.44, it's down to 0.3. It really does immediately demonstrate to you that the solubility of THC is far higher than the THCA. But let's look down at the collection. In this case, they had collected from 3 different vessels. The first vessel had 20% THCA. THC was 56%, not too unusual because we know that from the top ratio that we had a difference. But look at the ratio on the first and second, even though the numbers are different. It's 2.74 and 2.31. Remember when we started off with a ratio of 1.44. So you can see even within that, we have selectively dropped off the THCA into the first 2 vessels. And the third vessel is 13.27. So now we know that the THC we had selectively dropped off in the first vessels. But what's also different here is that the 2.74 and 2.31 are far too close together. So to be able to really do some differentiation, those 2 conditions have to be separated even more. Look at another example. Here we see the 3 different levels from the top, middle, and the bottom. And what really strikes out is the fact that they didn't test it before, so it was assumed to be around 8 on the percentage of total percentage. And now you look at the ratio, and you can see that there's channeling in the middle. And the THCA is definitely concentrated in the middle. And if you look at the bottom part on the collection vessels and start to not only look at the percentages, but also the ratio, you see that the first one is almost 4. And if you look at the second 2, it's around 2. So you know that you're doing a better job trying to force more of the THCA out into the first one, the polar, but you still need to work a little bit on the last 2 as those ratios are the same. And they have to be more differentiated in that to really work on the fractionation. So I'm looking at that, the analysis of products is certainly becoming increasingly complex. It's difficult to detect the columns. It's difficult to look at the complexity of the different types of ingredients that are in there, whether it's gummy bears or anything else that's in there, but also looking at some of the new tools that are available to help work through that entire process. And I thank you for attending. And as you're looking at that, your plan is typically really smooth and it looks wonderful. And typically reality is more difficult, but you can start to put through the bridge that goes across the front part, getting onto a transom to move to the second part across the ship. All those parts are much easier to do, as well as being able to navigate around them. And that comes mostly from looking at the preparation of the feedstock, so it's always within the same moisture. What's the grading? What's the liftoff and touchdown for distribution size, making sure that distribution size is comparable. It's also looking at the conditions on the extraction, from a very simple extraction to one that has more capability and more factors driven into it. And then also it gets you closer and closer to, once you have a process, you are going to get yourself closer to your own mechanical magic botanical filter. Your MBF has a possibility to be made for your process and your work. And with that, I'd be happy to answer any questions. My email is below and phone number, but also a website that's going up in probably the next 48 hours or so. So I'm more than willing to answer any questions that you'd have.
Right. Thank you very much, John. There's a little bit of feedback. Whose microphone? Okay, so we have a number of questions. First question is, where do we get the magic botanical filter? Is it at Target? Sorry, no, but first serious question, John. What's a reasonable budget to start and maintain an extraction line? Hold on, sorry.
Go ahead. Oh, now I'm unmuted. That's good. So when I'm looking at something like that, starting from scratch, it all goes back to what you're trying to make. So even the most formulations, and let's look at it as far as something that can be regulated for tinctures for a patient, so titrating something for that, and then being able to have something that might be 300 pounds a month, and put in a few simple testing, then the equipment out there today can vary from 80,000 to 350,000 for that, depending on the complexity and automation. And testing the equipment, it can be from 15,000 to again 100,000 for being able to put in different procedures for looking at terpenes, residual solvents, and looking at your own materials. So on the equipment side, it can be as low as 120 and as high as 550, and then after that you start to look at what you have for construction. And on the construction side, that can vary.
Okay. Sorry about all that. One second. Okay. All right. Next question. Should we use waste to make consumable products or reference standard? What's the application of using say secondary extraction components?
So let me see if I can go through that. It does sound like Houston, we've got a problem, but I'll see if I can decipher what you asked. So is it the question of what would be post-processing as well as accessories as far as standards and reagents for the scientific equipment? Was that the question?
Kind of. Sorry about all this. Jeez.
Different way. Because I did hear reagents and standards. So reagents and standards, so if you have something that's a liquid chromatograph, then you could be spending $300 to $400 looking at different number of standards. So you could have as many as 10 standards, or you could be just looking at 4 or 5. And so if you have something that's a liquid chromatograph or a GCMS for terpenes and testing residual solvents, and those standards could be that high. There's other technology out there that doesn't need to have the standards and reagents, but it gives you an answer within the plus or minus 1% of a 17025 basic library. And then also looking at qualitative. So even on the TLC, the size of the dot is an indicator of the amount of material. So all the way from something very simple to something down to plus or minus 0.1% of what is real. On the backside of post-processing with distillation and whether it's thin film or a short path, you're still looking at some capabilities of between $50,000 and $120,000 for something that's a real quality instrument.
Okay, thank you. Is it possible to make a low viscosity extract from cannabis without adding additives?
I'm thinking. So again, it's formulation centric. So a low viscosity additives, I don't entirely understand the question, but let's see if I can take a shot at the fact of whether you're doing a dilution afterwards and making a formulation from that, or just having a low viscosity directly out of extraction. Either one of those is again, it starts to move towards the magic extractor, and it's always going to have more upfront work. So being to do the upfront work on the viscosity means being able to know what the lipids and waxes are, and that would be evaporative light scattering detector, along with looking at more of the non-UV absorbing compounds and comparing those to the ingredients you're looking for.
Okay. I apologize for the feedback. Jeez. All right. If you can talk about training and working in an extract facility.
So training in a current facility or training in a company that's currently doing extraction.
Yeah. What could someone expect to be trained on to become very proficient at making extracts?
So I think some of the key parts of looking at training is typically within one day to understand the principles and practical aspects of extraction. So on my side, I usually use coffee and tea as indicators of how the extraction is working for cannabis. So it is very, very similar, especially when you start to move towards espresso. When you move from typical coffee with a certain grind and you place it through a French press and you add the water, and then after a certain amount of time you press it down, and then it goes through a filter and you take it out. That's extraction. A lot of people drink coffee in the morning, or if they didn't like all the other flavors and fragrances and the full spectrum experience, then they would just take they just take a caffeine pill. There's plenty of them out there, but people don't. They like coffee. The second part of that on the French press is that you are extracting out the material as well as the flavor. When you start to move through a flow through, you're now taking the coffee, you're placing it in, you have a filter, and you place the water over, and then the water goes down through the hole, and you collect it, and you move it through, and there's different espresso where the coffee grind is really, really fine, and you're having to use pressure. So those are the same thing as extraction. So the first day is typically just helping people make coffee and tea. So those are the basic principles. Then you start to move towards different solvents, CO2 versus propane versus butane versus ethanol versus fluorocarbons. Each one of those has a different solubility. The same way you have a different solubility based on the temperature of the water you're using with your coffee. If you want iced coffee, you don't put in coffee grounds and then put ice cubes on top. It's a matter of sequence of what you're trying to get. So on the first day, it's more of looking at how do you make coffee, and after that, moving it towards extraction. And it's like that bike ride that takes care of that first one where you're no longer having to go on the pond. You go around the pond. You know how to go around that, and you have a true visualization of what extraction is. And then moving from that, you just get better and better.
Okay.
Typically 2 days and you're well.
Well, I hope the feedback has gotten a little bit better, but it still looks like it's John, you showed on-site testing. Could you talk about why that's important? Should every cannabis operation have the ability to test their products on demand?
The quick answer is yes. And the longer answer is yes, because. And the because is that you want to make quality products. And so you want the products to be the same every time. When you open up a diet drink in California, you want to open the same diet drink in Boston and have the same experience. You're expecting the same. That's the same thing that customers are expecting from everybody's products. If they have a product on Monday and they go back and order that and have that product on Friday or 3 weeks from there, they expect the experience to be the same. They expect the therapeutic value to be the same. And the second piece is that as regulations get tighter and as margins get shorter, you're also wanting to be in extraction with efficacy as well as economics. So the economics means that you're able to stay in business and make a quality product that you're trying to make for the customers that you're trying to make it for. So to stay in business, you need the testing inside. To have customers have an experience that you're trying to perpetuate or to have as a business, then it's critical for that also. So I look at it like texting while you're driving down the highway. For a lot of people, they're still texting while they drive down the highway. So I encourage them to do the following experiment. I'm really not encouraging them to do the following experiment. It's a joke. But if you get up close behind a big truck on a highway, then just shut your eyes for 5 seconds and open them up and see where you are. Because that's exactly what happens sometimes when you're making a product and then you send it out to the lab, and after you've done the weeks of work, you find out that it's not what you wanted. You should have found that out way earlier and being able to make different changes and corrections along the way.
Oh, good. Very good. Thank you. Well, I do have one more question. Okay. But it's hard to ask that. Hard to listen to myself on a feedback loop.
I can hear you okay.
You can hear me okay? You can hear me okay?
Yes.
All right. I guess the other question we have relates to extracting for use instead of abatement. And if someone is filling out terpenes or buying them and then adding them to an extract, does that count as an additive? Or is that just a whole cannabis extract? Because sometimes people will extract out from a bunch of cannabis, make an extract of another variety, and add back terpenes. Do you have any thoughts on that?
I don't know the regulations on additives versus non-additives in that sense, and I don't think there are any, but someone should tell me if there are. And number two is, if you're adding terpenes, it's adding the terpenes in the same ratio which is most critical. So the myrcene, pinene, beta-caryophyllene, all those different ones. If it's an entourage effect, then you need to have those in the same ratio each time because they are part of that. To me, some of the other entourage effect means that the terpenes are the front wheel of the bicycle, the cannabinoids would be your rear wheel. Your front wheel is directing the experience, the back wheel could be your amplification in a simple sense. And I know that there's, exceptions to all of those. But if you go back through, you're adding it back into a process because you would lose it if you only did it way in the beginning. So, I mean, I as long as you write something on the container to tell people what you're doing, I think it's fine.
Okay, great. Thank you. Well, we have just a few minutes here before 8, and we have to close out the webinar. I don't see any more questions coming in. John, do you have any final questions from the audience? Where can people read more about explore your thoughts and ideas? Do you write for any publications?
I do. I write for a publication called Terpenes and Testing, and several other along the way. But the website should be up within the next 24 to 48 hours, and then that'd be a great place to ask questions, and can either funnel them through people who know more about them, or getting people connected to each other would be great.
Yeah, I believe they're called the Dear John letters.
Yes, there's also the Dear John letters on terpenes and testing. You can do that.
Excellent. Well, thank you, Dr. MacKay. A terrific presentation. I wish I had seen something like this when I started my cannabis career over a decade ago. So thank you very much.
Thank you very much.
We're all very lucky.
We're all very lucky to have your experience and insight.
Thank you.
And with that, closing the webinar. Thank you all for attending. We'll be posting this to YouTube after edit it a little bit, make sure it's clean and sounds pretty. All right, folks. Thank you so much. And we are going to go off the air shortly.